Hi guys, this is the second chapter of part 3. In this chapter we're going to talk about mole. We're going to focus on mole, which is very important. Okay, this is the link in every calculation. Now the first question we want to ask ourselves is the meaning of the word mole. Again, there's a definition to this. Don't really worry about the definition. If you can memorize it, excellent. If you can't, that's okay. So the mole is the amount of substance that contains as many particles as the number of atoms. I'll just put number of as the number of atoms in exactly 12 grams of carbon 12. Now, when I was doing my SPM as well, I memorized this definition. I didn't really understand what it meant. I didn't really understand this definition. I understood what mole is. So, what I strongly recommend you do is that you try to memorize this definition to the best of your ability. And as far as understanding what mole is, we will see how it works in calculations. Okay. One more thing you need to know about is the Avogadro number or the Avogadro constant. The Avogadro constant is simply the number of particles in 1 mole of a substance. Okay, now something interesting and very important to know is that the Avogadro constant is a constant. Okay, it has a value. This value is 6.02. Let me just write this down. 6.02 times 10 to the power of 23. This is the value of the Avogadro constant. So if you can memorize mole and Avogadro constant, go ahead. If you cannot, then it's okay, but do your best, guys. Okay, now we know that the Avogadro constant has a value of 6.02 times 10 to the power of 23. Now we need to understand how the calculations work. Okay, so for the first set of calculations, what I'm going to do is we're going to have the number of moles. Okay, number of moles, and we're going to have the number of particles. Now I want you guys to pay special attention to this. Remember, in terms of particles, we have atoms, we have molecules, and we have ions. So this rule works a little different based on atoms, molecules, and ions. Okay, students, pay special attention to what I just said. Now, how do we get from number of moles to the number of particles? What we do is we multiply the number of moles with our Avogadro constant, which is 6.02 times 10 to the power of 23. Now, how do we get from the number of particles to the number of moles? We divide our number of particles by the Avogadro constant, which is 6.02 times 10 to the power of 23. So we understand this, we know how this works. Let's look at some examples. Again, like the previous video, I will read out the question, so you guys just write it down, try to think of it, and we compare answers. Okay, so a sample of oxygen gas contains 3.01 times 10 to the power of 22 oxygen molecules. Okay, so again, a sample of oxygen gas contains 3.01 times 10 to the power of 22 oxygen molecules. This is the number of particles, right? How many moles of oxygen molecules are there in the sample? So we want the number of moles. We have the number of particles. To find the number of moles of oxygen, divide this number, which is the number of particles, by the Avogadro constant, which is 6.02 times 10 to the power of 23. You end up getting 0.05 mole. This is your number of mole. Does that make sense, students? Okay, if it doesn't, we just keep looking at many more examples. We will get the hang of this, okay? Next question. A gas jar contains 0.2 mole of carbon dioxide. So, they've given us the number of mole of carbon dioxide. Find the number of molecules in the gas jar. So, how do we find the number of moles? We have the how do we find the number of molecules? We have the number of moles, which is 0.2. To find the number of molecules, which is the number of particles, we multiply the number of moles by 6.02 times 10 to the power of 23. We get our final answer to be 1.204 times 10 to the power of 23 molecules. Now, this question has a second part to it. I'll repeat the question. A gas jar contains 0.2 moles of carbon dioxide. Find the number of carbon atoms and oxygen atoms that make up the carbon dioxide in the gas jar. Now, notice the difference between the words molecules and atoms, okay? So, we're talking about carbon dioxide. So, let me just write down the chemical formula of carbon dioxide, CO2. This is one molecule of carbon dioxide. This one molecule of carbon dioxide is made up of one atom of carbon and two atoms of oxygen. Therefore, we have three atoms in one molecule. Okay, I hope that makes sense. So, to find the number of atoms, what we do is we take our number of molecules, which we got in the previous question, to be 1.204 times 10 to the power of 23, and we multiply it by 3 because we have 3 atoms, and we get our answer. Let me check. Or you can do it separately as well. Nothing wrong with that. So if you were to do it separately, 1.204 times 10 to the power of 23 times 2 for 2 oxygen atoms, you get 2.408 times 10 to the power of 23 oxygen atoms. As far as carbon atoms are concerned, you still have 1.204 times 10 to the power of 23 times 1, because we only have one atom of carbon. So we get 1.204 times 10 to the power of 23 carbon atoms. Does that make sense, guys? You can also multiply it by 3 to find the whole thing, or you can break it up into 2. That is the big difference between finding the number of molecules and finding the number of atoms. It works the same way for the number of ions as well. It's not like the number of molecules. It's similar to the number of atoms. Let's look at a question. 0.4 mole of copper 2 chloride. So copper 2 chloride is CuCl2. Okay. 0.4 mole of copper 2 chloride is dissolved in a beaker of water. Calculate the total number of ions present in the beaker. Total number of ions. How many ions do we have right now? Well, we have one ion of copper, okay, and we have 2 ions of chlorine. Therefore, we have 3 ions, 1 plus 2, okay, 1 plus 2. So we have 3 ions, we have 0.4 mole, right? And we want to find the total number of ions, which is the total number of particles. So to go from mole to particles, we multiply 0.4 times 6.02 times 10 to the power of 23. Are we done yet? No. We don't have one ion. We are finding the number of ions, right? We have 3 ions. So multiply this by 3. We get our final answer to be 7.224 times 10 to the power of 23 ions. Now, try not to memorize this, guys. This is very straightforward. If you memorize it, you're not going to get it. Okay, understand it. We started off with the basics. Now we're building into it. When we're going to build more and more into these equations and calculations. But once you get it, once you realize it's all dependent on number of moles, you're going to enjoy it. It's going to become addictive. Okay, so let's keep going. Let's see what happens. Okay, I'm going to give you another example. So I have a compound, let's say water. Water is H2O, and I have the number of moles of H2O to be 0.5 moles. Okay, so I ask you, find the number of molecules of water. B, find number of atoms of water. And C, find number of atoms of water. Same thing, guys. Okay, when we get from one, if you want to go from moles to the number of particles or the molecules, we just multiply with 6.02 times 10 to the power of 23. So for the first part, part A, all you do is 0.5 times 6.02 times 10 to the power of 23, and we get the number of molecules of water. For the second part, the number of atoms. We have 2 atoms of hydrogen and 1 atom of oxygen. So we have 3 atoms in total. Whatever the answer you got from part A, that answer should be multiplied with 3. The same thing with part C. Find the number of, not atoms, sorry, the number of ions. We have 2 ions of hydrogen, 1 ion of oxygen, so 3 ions. So whatever the answer in part A, multiply 3. You notice that the answer in B and C is the same? Exactly, students. Now you're getting to see the link. Keep it up. Let's keep going, okay? Alright, students. The next topic, molar mass. Now, the way to understand molar mass is to look at the formula of molar mass. Molar mass, and this is what I would do. I would just look at the unit. Molar mass equals to gram per mole. What does this mean? This is the unit, gram per mole. If we translate this into words, molar mass is equals to mass over number of moles. The unit of mass is grams, the unit of number of moles is mole. So molar mass equals to gram per mole. What is molar mass though? Guess what? The value of molar mass is the same as the value of your nucleon number. It is the value of your relative atomic mass or the value of your relative molecular mass. Remember how we said that relative atomic mass and relative molecular mass is simply the value of our nucleon number? The value of our molar mass is the same thing. It's the same number with the units gram per mole. So if I ask you, what is the molar mass of magnesium? Okay, you look at your periodic table, look at your nucleon number. Your nucleon number is 24. So your molar mass is 24 with the unit gram per mole. What is the molar mass of carbon dioxide? So we look at it individually, we have to add them, right? Carbon's mass is 12, oxygen's mass is 16. So 12 plus 2, because we have 2 atoms of oxygen, times 16. 12 plus 32 is 44. So this is our relative molecular mass, and it's also our molar mass. Therefore the molar mass of carbon dioxide is 44 grams per mole. Make sense, guys? So you just need to memorize this formula, and we will play with this formula. We keep switching. When you are given the molar mass and you are given the number of moles and you're asked to find the mass, how do you find it? We use math, cross multiply. Mass is equals to molar mass times the number of moles. If I give you the mass and you know the molar mass, how do you find the number of moles? Again, math. Moles will equal to mass over molar mass. You see it, students? You understand the connection? Let's look at some questions. I love doing these questions. When I was in Form 4, guys, I was addicted to these questions. It was fun, especially when I understood it. I hope you guys understand this, okay? So, again, same drill. I read the question, you write it down, pause, we discuss. Question 1. What is the mass of 10 moles of water? So, I'm given the moles, this is water, so I write the formula H2O. I'm given 10 moles and I want to find the mass. So let's see what I have. I have the moles. Can I get the molar mass? Of course I can. Molar mass is just the relative molecular mass of water. 2 times 1 plus 16 equals to 18 gram per mole. And if you don't know how to get this, please watch my previous video. So molar mass is 18 grams per mole equals to mass, which we don't know, over number of moles, which is 10. So how do we find the mass? We just cross multiply. So x equals to 18 times 10, x equals to 180. Are we done yet? No. The unit is very important, students, and the unit of mass is grams. So always don't forget to put the unit down, okay? You understand this, guys? Awesome. Keep going, keep pushing. Okay, after SPM you can do whatever you want. Now is the time to focus. Next question. Find the number of moles of sodium hydroxide with the mass of 2 grams. So sodium hydroxide, chemical formula is NaOH. Again, guys, don't worry about how to form these chemical formulas. We'll get to that. For now, I'm just going to write them down. I'll explain how to form them later. So sodium hydroxide is NaOH. We know the mass of sodium hydroxide is 2 grams. Do we know, and we want to find the number of moles. So let's think. I have the mass, I need to find the moles. Can I get the molar mass? Of course I can. Now I'm just going to do a quick, I'm not going to explain it step by step to find the molar mass. You guys know how to do it. Sodium hydroxide is sodium, which is 23, oxygen, which is 16, and hydrogen, which is 1. So 23 plus 16 plus 1 is 40 gram per mole. This is our molar mass. Molar mass equals to mass over mole. So 40 equals to 2 over x, the number of moles. So to find number of moles, 40x equals to 2 and x equals to 2 over 40. 2 over 40 equals to 0.05 mole. And now you found the number of moles. Next question. What is the mass of copper that has the same number of atoms as in 4 grams of argon? Okay, this question is a bit wordy. What is the mass of copper that has the same number of atoms as in 4 grams of carbon? Let's just write down what we have. We are dealing with copper, so I'll write down Cu. We're dealing with argon, so I'll write down Ar. We want to know the mass of copper, so M, we don't know what it is, that has the same number of atoms as in 4 grams of argon. So we have the mass of argon to be 4 grams. Do we have the molar mass of argon? Yes, we do. Look it up the periodic table. It's your nuclear number. The molar mass of argon is going to be 40 grams per mole. So think, guys, think for a second. Remember I said that there's a link connecting everything in chemistry. That link for calculations is always, and I repeat, always number of moles. Number of moles links things. So now we want to find the mass of copper. How do we do that? We need to get the number of moles of argon, and that number of moles of argon are going to be the same as the number of moles of copper. Why is that? Because the question says has the same number of atoms. What is the definition of mole? Amount of substance that contains as many particles as the number of atoms. You see the definition, guys? It's linking. So find the number of moles of argon. The number of moles of argon equals to the number of moles of copper. Let's do that first. 40 grams per mole equals to mass, which is 4 over mole. We don't know what that is. So 40x equals to 4, x equals to 4 over 10, which is 0.1 mole. So if argon has 0.1 moles, it means that copper has 0.1 moles. So moles equals to 0.1 moles. What does the question want us to find? The mass. So think, we have the moles of copper. We know the molar mass of copper by looking at the nuclear number of copper. So molar mass equals to mass over mole. Molar mass of copper is 64. Mass we need to find, so x, number of mole is 0.1. To find the mass, cross multiply. 64 times 0.1 is 6.4 grams. Get it, guys? Awesome. We're going to do one more question like this. That's a little, these kind of tricky questions. So what is the mass of hydrogen gas that has twice the number of molecules as in 3.55 grams of chlorine gas? So we're talking about hydrogen and chlorine. Always break down the problem, guys. We're talking about hydrogen gas, which is H2, and we're talking about chlorine gas, which is Cl2. We want to find the mass of hydrogen. So mass equals to question mark that has twice the number of molecules. The keyword is twice. Do we have the mass of chlorine? Yes, mass of chlorine is 3.55 grams. Do we have the molar mass of chlorine? Yes. Look up the nuclear number, you get 35.5, but hold on a second. That is for Cl. We now have Cl2. So 35.5 multiplied by 2. So the molar mass is going to be 35.5 times 2, which equals to 71 grams per mole. Can we get the number of moles of chlorine gas? Yes. 71 equals to 3.55 over x. X equals to 3.55 over 71, which equals to 0.05 mole. Now we found the number of mole of chlorine gas. In the question it says the mass of hydrogen gas that has twice. That means the hydrogen gas is going to have 2 times the mole. The link, remember the link is mole. Everything has to do with mole. You connect two things by mole. So twice the number of molecules, so the mole is 2 times more. If the mole of chlorine is 0.05, the mole of hydrogen is 2 times 0.05 because it's twice, which equals to 0.1 mole. Now we have the mole of hydrogen, we need the mass. So think, what's the link? Molar mass of hydrogen. Do we know it? We know the nuclear number of hydrogen is 1 and we have a 2 over here. So the molar mass is 1 times 2, which equals to 2 grams per mole. This is the molar mass of hydrogen gas. 2 equals to x over 0.1. Can we get the mass? Obviously, cross multiply. 2 times 0.1 equals to 0.2 grams. There you have it.